Now we're going to get into the portion of the module where we're actually working problems associated with friction and forces that are required to get objects moving or to keep them moving. I'm actually going to put this video into 3 separate segments so that hopefully it will be a little bit easier for you to find the portion that you need in case you don't need to watch all of it. So I'm going to start out here by just giving you a general summary of frictional force and how we're going to calculate frictional force. And then I'm going to work the first part of example 5.5. I'm going to work the second and third parts of example 5.5, but I decided I'm going to put them into separate videos, again, just so that they're a little bit easier for you to navigate in case you don't need to watch all of it. So I'm going to start out with just a general overview. We know that when we talked about friction, we said that the amount of frictional force that surfaces have depends on those specific surfaces. And so the frictional force, as we'd already said, is related both to the nature of the surfaces, and the nature of the surfaces is given to us by the coefficient of friction. And it's also related to the weight of the object, and the weight of the object on a level surface is going to be equal in magnitude to the normal force. So the coefficient of friction is represented by the lowercase Greek letter mu, and you have to be sure if the problem gives you both that you decide whether you're going to use the coefficient of static friction, which will be mu sub s, or whether you need the coefficient of kinetic friction, which will be mu sub k. Keep in mind that the static frictional coefficient is always going to be greater than the kinetic frictional coefficient, because we said static friction is always greater than kinetic friction. It's harder to get something to start moving than it is to keep it moving. So if in the problem the object is not moving and you're trying to get it to move, you're going to need to use the coefficient of static friction. If the object is already moving in the problem, then you're going to want to use the coefficient of kinetic friction. Okay, so frictional force is equal to the coefficient of friction times the normal force. So in example 5.5, in the first part of that, in this particular example, our object is not moving yet. That's the whole point of the problem, because it says a 300 kilogram log rests on the ground, and then it gives us the coefficient of both static and kinetic friction. What is the frictional force that a pulling truck would have to overcome in order to get the log to move? Now, when you start working these problems, I mentioned before, it's always a good idea to draw a picture so that you have a note of every single thing that is actually going to be affecting this log. Now, a lot of times in the example problems, he gives you a picture already. You're not often given a picture in the other problems you're expected to work. So that's the first place you need to start. So I'm going to put my log here on the ground, and we need to first diagram all of the forces that are acting on this log. So first of all, I know that gravity is pulling on the log. So that is going to be the weight of the object. The object isn't moving in a vertical direction, and so therefore the normal force is going to be acting upwards on the object. The truck, actually the truck was over here. I didn't put the truck in here. There's my very odd looking truck. Okay, so the truck is pulling this direction, and so he is applying a force this way. And because the object is sitting on the ground, the log is not sitting on a frictionless surface, there's going to be friction involved. And so the friction is going to be acting in a direction to oppose the motion, and we define that by a lowercase f. Okay, so this is all of the forces that are acting on this particular log. I've been told that here's the mass of the log, 300 kilograms. I've got both of my coefficients of friction, and what I am asked is how much force, what is the frictional force that he has to overcome in order to get the log to move. So basically, he's going to apply a force here to overcome this force over here. So what is the frictional force? Well, the frictional force that he has to overcome is going to be given to us by the coefficient of friction times the normal force, okay? So, which mu do I want? Do I want the one for static friction or do I want the one for kinetic friction? Well, is the object yet moving? It is not. So if it is not moving, then I need to use the coefficient of static friction. So I need to use the 0.74, and coefficients of friction do not have any units on them. Then I need to know what the normal force is. Well, how did I find the normal force before? Well, I said it's the normal force is equivalent in magnitude to the weight. So therefore, I need to find the normal force, which is going to be equivalent to the weight, which is going to be mass times gravity. So therefore, that's going to be, the normal force is going to be 300.0 kilograms times 9.8 meters per second squared. So that then will give me a normal force of 2,900 newtons. Okay, so there's my normal force. Now I can go back and I can plug that in here. I really didn't allow myself quite enough space, did I? So there's 2,900 newtons that gets plugged into this equation. And now I can find the frictional force just by multiplying those two together. 0.74 times 2,900 newtons is going to give me a frictional force of 2,100 newtons. So what that tells me is that this truck is going to have to exert a force just slightly greater than 2,100 newtons in order to get the log moving. If the two forces are exactly equal to one another, they will cancel each other out, and so he won't be able to get it moving until he actually overcomes the frictional force. So that's why I say that he has to apply a force just slightly greater than 2,100 newtons in order to get the log moving. Okay? If you need to see the second and third part of this example, then you need to go on to the next two videos.